Hi guys, welcome to Tutes Online. Today I'll be talking about Thevenin equivalent circuits. So the basic idea behind finding the Thevenin equivalent circuit is to simplify a circuit which may have multiple resistors and multiple sources of current or voltage into something that simply has a voltage source and a resistor. We call this voltage source V Thevenin and the resistance R Thevenin. And so when you're looking at the outputs of this circuit, it would be the same as if you had one which may have heaps of resistors in parallel, different voltage sources, etc., etc. So we'll look at the first example. We have a 10 volt source, resistor here, and when you draw this, you leave it with no load attached, so this is just the voltage output. And this is R1, which we'll call 2 kilo ohms, and R2, which is 10 kilo ohms. So step 1 is to find the output voltage. So V out would be a voltage divider, so that's R2 over R1 plus R2 times by the voltage that we have, which is 10k over 2k plus 10k times by our voltage, which is 10. That's equal to about 8.3 volts. So this is our V Thevenin value. Step 2 is to sort of turn off our voltage or current sources. So if it's a voltage, we short, and if it's a current source, we open circuit. So in this case, we just have a voltage source, so we'll write that as just simply a short circuit. We still have our resistance there, the one in parallel, and that's it. This is 2k, it's 10k, so R total is equal to R1 times by R2 over R1 plus R2, which is 2 times by 10 over 2 plus 10, and that'll give you a value of approximately 1.67 kilo ohms. So this value is our R Thevenin. So now we've found the equivalent voltage and resistance, we can put it into a single circuit. So we have a voltage source and resistance, and that's 8.3, and this is 1.67 kilo ohms. So that's example 1 done. We'll look at another example. This one will have current source in parallel with a resistor, as well as a voltage source, and our output voltage. And we'll put another resistor in here. So this could be 1 amp, 2 ohms, 3 volts, and we'll say 4 ohms. Now it's sometimes easier to do what's called a source transformation. So this allows you to turn something like this into something like this. So you change a current source to a voltage source, and you just simply apply I equals V over R, or V equals IR, depending on which way you're going. So we'll do that to the current source to make it a voltage source. The result would be a voltage source. Notice the direction of the arrow here, so that'll mean it's a minus plus, unlike here which is a plus minus. The resistor is now in series, and we've got our 4 ohm resistor, our other voltage source, and the output voltage. So that's still 2 ohms, this is 4 ohms, And this one's V equals our current 1 times by the resistance, which is 2, versus just 2 volts. And this one's 3 volts still. Now because this is essentially an open circuit here, all the current will be going down here, along here, and all of it will go up here in this sort of loop. These two voltage sources will add, so you'll have 2 volts plus 3 volts equals 5 volts. To find the resistance, we short circuit our 2 voltage sources. So that's just short circuit, a resistor, our other resistor, short circuit. And these two are in series, so it's just simply 2 plus 4 equals 6 ohms. This is our Thevenin, and this is our Thevenin. And so we can write this circuit as simply 5 volts, 6 ohms, and so that's our Thevenin equivalent. And it's possible to convert this to a Norton equivalent. So to convert from Thevenin to Norton, you would write, instead of this voltage source, you'll have a current source with a resistor in parallel. Just like we did with the source transformation, this would still be 6 ohms, and the current, I, would be equal to our voltage, 5 over 6, which is about 0.83 amps. So that's it from me. If you have any questions, post a comment, please subscribe and visit the website. Thanks.